Hello, everyone. Thank you so much for joining us today. I am so honored to be here with Rob Metzinger, President and Founder of Safe Living Technologies. Thank you for joining us.
Hi, Theodora. Hi, Theodora. Oh, thank you for having me. It's a pleasure to be here today, and I look forward to this. What I have today is I've got a PowerPoint presentation, and then first we'll start off with the ultimate importance of measuring RF and some factors to understand about it. Then we'll look at some basic RF theory, and then we'll get into looking at the meters. And afterwards, there'll definitely be time for questions. So save your questions, and we'll try to get to as many as we can.
Great. Well, while you bring your slides up, Rob Metzinger is President and Founder of Safe Living Technologies, and he's going to share with us how to use electromagnetic radiation meters. He has 20 years experience as an independent corporate electronics field service engineer. He is a certified building biology environmental consultant, a certified electromagnetic radiation specialist through the Institute of Building Biology, and has been an instructor at the Building Biology Institute, United States since 2010. And I was introduced to Safe Living Technologies a decade ago when I myself was looking on how to measure and understand what fields I was exposed to in my environment. And I'm so thankful for actually the help that you gave me when I needed to shield my apartment. So thank you. Thank you for joining us.
You're very welcome. And yeah, we talk to dozens of people a day that need help with this. And yeah, it's unfortunately it's a technical matter. It can be complicated, and there's certain basics you need to understand before getting started. So I'll try and take you through some of that today. And should I just begin right now, Theodora?
Yeah, please do. And you might want to make the presentation slide, make it in presentation style. Perfect.
Yeah,
great.
You got it.
Okay.
Yeah, for sure.
You can put questions in the chat, and when Rob is done, we will do questions.
Okay. No, it sounds good. Well, I'll try and keep this to around the 30-minute mark, and we'll have lots of room for questions afterwards. But yeah, this picture is one of the locations we held one of our building biology seminars. It's Chimney Rock in North Carolina. So it's a beautiful location. We're going back there again this year for more building biology courses. So yeah, just very, very scenic. And first thing is understanding the importance of RF measurements. So why do we even need to do this? And so the issue is these fields are invisible and only detectable with a measuring device called an RF meter. And by using these meters, it allows you to see your level of exposure, for one thing. So it'll give you a digital readout in most cases, or an LED readout in some cases. And the meters allow you to hear the sources. They have an audible feature to them. So it converts the digital signals of the sources to different audio sounds, and each source has its own unique sound. This is the modulation pattern, or the data or information packets that are traveling through the air. And yeah, it's like electricity in the air. So that's kind of what we're measuring. We're measuring the density of electricity in the air around you, in like a square meter. Is kind of our standard unit of measurement, microwatts per square meter to be more clear. So yeah, you can't see it, can't feel it, can't taste it. So if it appears not to exist, it's out of sight, out of mind, and we don't want that. So we want to make the visible, or make the invisible visible, and that's what these RF meters can do for us. So, this, RF in the environment, it's a valid environmental toxin, but unfortunately, it's not really a publicly recognized one. And that's what Theodora and Environmental Health Trust is trying to do. They're trying to get the word out about this problem, which they're doing a fantastic job with. And another reason, it also causes biological effects at a cellular level. So it affects our basic building blocks of life, right down to the cellular level. And it doesn't just affect the electrically sensitive, it affects all of us. And we all need to be concerned with this. Prevention is way better than trying to solve a problem that exists. So if you don't suffer from sensitivities, consider yourself very lucky, and try to take precautions to reduce your exposure. You know, we're beings of resonance. Various systems in our body operate at different electrical frequencies, and these external frequencies that are hitting us can interfere with the body's internal communication systems. So that's another reason why it's so important. And also, you need to hear and see it and measure it in order to mitigate it. So one thing we're big on is an engineering approach to this, which means you measure a source, you get rid of it or shield it, and you remeasure it. And it's really important to do that. Then you know for sure that you've got the source of the problem. So that's kind of the basis behind all of this, and behind what we do, and behind the products we carry as well. So to start with, if we're to look at the electromagnetic spectrum, and here we go. So we start, this is where the electromagnetic spectrum defines how the various frequencies of radiation fit together on the basis of frequency. So here we can see the different frequencies, you know, starting at 0 hertz, which is DC. And what we're measuring is AC fields. Radio frequency is AC, and electric and magnetic fields, we're going to be assessing the AC component. That means it comes from AC electricity, and it has various frequencies. It cycles positive to negative. In the case of power, 60 times per second. You know, in the case of cell phones, it's in the gigahertz range. You know, millions and billions of times per second. So here we can see the frequency at the DC level at 0 hertz, and then we can see it increase up here. We have power line frequencies, we have dirty electricity, then we have AM radio in the kilohertz range, and we have FM radio in the megahertz range. Then we have our TV and cell phone towers, cell phones, Wi-Fi, microwave ovens as well. And then we get into to infrared and visible light, and then radioactivity here. So we know this section over here is bad because it's ionizing radiation. There's studies, and we're all familiar with that. It causes cancer, most definitely. The issue is convincing people that this non-ionizing radiation causes the same effect or causes harm. That's been our challenge over the years. And you know, we certainly believe it does in dealing with these electrically sensitive people for as many years as we have. So there's no doubt in our minds. And so here we see the frequency as it increases. Other thing to know and understand about measuring radio waves is that the wavelength decreases. So here we can see a sine wave of the frequencies, 60 hertz. You know, that oscillates positive and negative 60 times a second. And then it increases and increases. And gradually, as you go through the spectrum, it decreases into very, very small waves, you know, millions and billions of oscillations per second. And that's what radio frequency waves are, basically. They travel through the air on a carrier wave, and they carry information. And the frequencies are in the millions and billions of times per second, cycles per second. So as we go to our next slide here, understanding the distance or the length of these waves is important. So the meters we have are far field meters. So we want to stay in the far field of a source when we're measuring. So this is important because, you know, the near field would be within 3 wavelengths of a meter. Within 3 wavelengths of the source. So each source has its own wavelength, and we can see here, I did the calculations, the different wavelengths for different frequencies. So power frequencies, they have separate electric and magnetic fields. So at the far field range, this is where they tend to meld together. And we can see that it would take, 9,300 miles for to be in the far field for power line frequencies. So basically, we're always in the near field when we're measuring, and that's a different case. All of these, most of these signals here. Let me just get my annotate working here again. You can see 60 hertz all the way up into the kilohertz range. This is where we measure with EMF meters, and below here, this is where we start to measure with RF meters. So, a 300 megahertz wave is the far field is around, say, about 10 feet, and as we get to 850, it's around 42 inches. Then we get to 1.8 or 2.4 gig, it's about 15 inches. And the only reason I mention this is because if you're doing measurements and you're going to present them in front of some type of entity or a significant body that's going to analyze these, you want to make sure you're doing your measurements properly. So technically, you do need to be in the far field when you're measuring these sources with our meters, because they're far field meters. So you just don't want to be too close to the source. There's no reason why you still can't put the meter close to the source and watch the reading go up, because it'll go sky high. But in the far field, it's kind of a more uniform field, and it's kind of equal. If it's transmitting 360 degrees equally, it'll be easier. You'll get more consistent measurements when you measure at that distance, as opposed to going to it too closely. Then you're going to measure some hot spots, and it may be too high or it may be too low. So that's why you kind of need the distance from these things in order to measure them. And that's no issue with cell phone towers. We're always far enough away to measure them. It's just the cell phones themselves. If you have the meter right up to the cell phone, technically it's not a valid measurement, but it gives you a good idea how strong they are, though. So I believe there's some good in doing that as well. Also, another important thing to understand is peak versus average. The industry uses average power, and this graph will kind of give you an indication of how different they can be. When you're measuring pulse digital signals, it's very misleading on measuring on using average measurements. And on our safe and sound meters, we do give a peak measurement and an average measurement. And this is an example of a Wi-Fi beacon signal. So the Wi-Fi beacon signal pulses 10 times per second. And we can see them here. They're approximately, in this case, as an example, 10 milliseconds per pulse. So you can see that let me annotate working here. You can see that the highest peak would be called the maximum. So if we do a measurement over this period of time, our maximum value is going to be the highest value over this period of time. In this case, it just happens to be the first measurement, but that's the max. But the live measurements are the peaks that you're going to be measuring, and you're going to be measuring these items here. And you can see how there's so much dead time in between these pulses. You can see that the average measurement is basically the average of everything together, the dead time as well as the electrical pulses that are happening. So, and you can see that the reading is much lower and much more misleading if you use average readings compared to the maximum, because for electrically sensitive people, we definitely need to look at the peaks, and we need to look at the maximum when you're doing these measurements. So that just gives you an example of the importance between peak and average measurements. So I wanted to get that into your heads first. Then, all these measurements are great, but, if you don't have guidelines to compare them to, it really doesn't do much good for you. So when I started this business, I started looking for a set of guidelines that I could use that I know would help people, especially electrically sensitive people. So came across the building biology guidelines from Germany. They're currently the SBM 2015 guidelines. And I believe there's going to be an update coming up in the next year or so. So I don't expect this to change very much, but you can see that they're very strict. If you look at point number 3 there, the United States and Canadian government guidelines are anywhere from 2 million to 10 million microwatts per square meter. And that's kind of the unit of measurement I'm going to go with for this presentation, is microwatts per square meter. And I'll explain that a little bit more in one of the future slides. But so building biology guidelines ask us to get to 0.1 microwatts per square meter, which is really difficult to do if you've ever done any of this measurement. So that would be the ideal or no concern level. So we're shooting for a slight concern level. If we can get our readings to 0.1 to 10 microwatts per square meter, we're in the good books with electrically sensitive people. It's usually a comfortable environment if we can get it down to that level and it doesn't disturb them that much. If somebody's extremely electrically sensitive, then we may have to strive to get below 1 microwatt per square meter. But so that's the radio frequency guidelines there. And the Bioinitiative report is also a great report to look at. Thousands of studies, and they've found levels down to 3 to 6 microwatts per square meter have biological effects. So certainly this 1 microwatt per square meter we're trying to shoot for is realistic as a, there are health effects still in that range. So we definitely need to try and get that low if we can. If we now look at AC magnetic and AC electric fields, so these would be sources from power, anything that uses power, power lines, wiring in your home, things like that. Typically we measure in milligauss, and our ideal goal would be less than 0.2 milligauss. Slight concern would be 0.2 to 1. So if you're in that range, we're generally happy with that. And electric fields, that would be, again, in the slight concern range of 0.3 to 1.5, somewhere in that range. And, again, Canada and the US governments, there's not really any established guidelines, but they use the ICNIRP guidelines, which are around 800 to 1,000 milligauss and close to 5,000 volts per meter. So you can just see the difference between the guidelines that we try and get down to compared to the government guidelines. So there's big discrepancies there, and that's part of our challenge as well too. We want to try and get that changed if we can. I know Frank Clegg has always been working on that and is striving to do that. And I believe he's part of Environmental Health Trust at this point. Would I be correct with that, Theodora? Okay.
Yes, he's on our advisory team. Yeah.
Perfect.
Could you mention where people can find these exceptional documents that you're sharing? Because I was just looking online to put a link in the chat for people.
Earlier, I sent you the PDF of this PowerPoint. Would that be acceptable?
Sure. Do you have these? You used to have them on your website.
We do, yes. Okay. So this document right here is under the education section, and it's EMF RF conversion tables. So sorry, I should have put the link in here too. Apologize for that, but the yeah. So if we look in the middle here, we've got microwatts per square meter. So that is typically what our meters measure in, and typically what building biology guidelines are in. The industry tends to use, what do they use? Milliwatts per square meter, watts per square meter, could be milliwatts per square centimeter. So what this table does is basically it helps you translate units of conversion. And so, if you've got a 10 microwatt per square meter signal, you print this out, or you just take a ruler and you can go along here and you can, find out what each of these values are in even volts per meter. So we know 10 microwatts per square meter is approximately 0.0614 volts per meter. So just a handy little tool in order to make things easier for you to understand these RF measurement units. So now getting into the meters a little bit. About 2 or 3 years ago, we came out with this meter. It's the Safe and Sound Classic, and it's now called the Classic 2. This is our new version of this meter. Each year we try to update it, and so we've put the speaker in the front on this new version. We've added more LEDs, and so yeah, we've kind of tried to make it a little bit of a better meter. than it was in the past. Increase its volume of sound that it broadcasts as well. So this one it's $159 US, and it's economical and easy to use. And we tried to make it for people that don't have any technical experience. So basically there's 8 LEDs on it, and they're all lit up here. And typically you'd only see one or two lit up. So green is good, red is bad. So again, here we are in the 10 and below microwatts per square meter. So this is kind of the range you want to be in. And then we get into the higher levels here. So this is where we get into areas that we probably don't want to spend a lot of time in. And so there are 8 color-coded LEDs, and you can see the measurement ranges or the exposure ranges that each LED offers. And when we built these meters too, we wanted to make sure we were sensitive enough to go below building biology guidelines. So we need to get down below 1 microwatt per square meter. And yeah, if you have a flashing green light, you're in a great area there. You're going to get below 1 microwatt per square meter. And another important thing too is it has to capture fast pulses, because all these pulses that we're getting hit with, they're getting faster and faster. So you have to make the detection circuitry fast, so it captures all these 5G pulses and all these other microwave pulses that are out there now too. So that's really important to do. And it does have a sound signature analysis to assist with source identification. So that's built into it. You can turn the sound on, you can turn the sound off with this switch here. Has a flat frequency response, and we've definitely lab tested it. It's 5G ready, and what I mean by that is it detects the low and mid bands of 5G. So the high band of 5G is pretty tough because it's millimeter wave, and the meters you need to detect that are very expensive. And we don't have anything in order to do that at this point in time. But just so you know that, the majority of 5G out there is all below 6 gigahertz at this point in time. Probably 99%, maybe 99.5%. There's only a few installations in some major cities across the US that actually do this. And this 5G technology in the millimeter wave band, I just don't know how it was supposed to work from the beginning. It seemed like a technology born to fail, because you have to be in direct line of sight with the towers. You'll drop your signal quite easily if you're not. And if you turn your back on the tower, you could block the signal with your body. Has difficulty penetrating buildings. So the good thing is there's not a lot of it out there. On the other hand, it has difficulty penetrating building anyways. So you really don't, it's not really the main concern. The main concern is a sub 6 gigahertz cellular band, and 5G and 4G LTE in that band. So what we do is we calibrate each unit individually in a special anechoic chamber. So that gets done, and there's a calibration certificate that comes with it. Another good thing is it's all made here in North America. So we get the boards made in Silicon Valley in the USA and California, and it's manufactured here in Cambridge, Ontario. And so it's Canada and the US, that's where everything is made. And well, unfortunately, some of the electronics have to be pulled from overseas, but that's just as good as we can get, unfortunately. And also it has an environmentally friendly design. So when you're holding it as well, we'd like to hold it right at the bottom with our thumb. And also the direction of best detection or best sensitivity. We, at the front of the meter, at the back of the meter. So basically in front and behind of the meter, that's basically where you're going to get the highest readings. So you'll have to angle it and turn it, and I'll show you how to do that with some videos and an explanation in the upcoming slides here. Okay. So then we came up with the same measurement technology, the Safe and Sound Pro, and we're at the Safe and Sound Pro 2 meter. The cost is $385. This has been a very popular meter for us. We've been very fortunate in that manner. And I'll just explain to you the features of it and how to properly use it. So it's effective from 200 megahertz to 8 gigahertz. The true frequency response is 400 megahertz to 7.2 gigahertz at plus or minus 6 dB. That might not mean a lot to you. I wouldn't worry too much about that, but basically there's a graph down at the bottom here that shows you the frequency response of that meter in a third-party certified lab. Each unit is individually factory calibrated in a small anechoic chamber as well. We include a calibration certificate. And it has the same features as a classic, plus others, which actually gives you a digital readout as a 4-line OLED bar graph of the RF intensity. It has a max hold and live peak measurement. They're measured in microwatts per square meter. It has a headphone jack. It shows you the battery level when you start it up. It shows you the voltage on the battery. So it lets you know how much battery life you have left. One of the great features of this too is you can run it 24/7. It has a USB power jack for continuous power monitoring. There's no data that can come in and out of it yet at this point. Data logging is on our mind for the future, but at this point we don't have that. So this USB jack just powers this device, and you can use it as a continuous monitor. I have one sitting on my desk usually all the time. Well, actually, no, I'm using one of our Safe and Sound micros on my wrist most of the time as well to monitor my exposure. And I forgot to put it on today. It's upstairs charging on my my computer upstairs. I might pop up and get that at some point. But it also measures up to 2.5 million microwatts per square meter, and that will increase to over 3 million with our newer model. And our newer model also measures in volts per meter instead of microwatts per square meter. So just a couple different measurement options there. And it does have good quality audio, which is what we really wanted to have with this meter as well. So, so how to use this, and when you're using it, the best direction of sensitivity. So again, just like the classic, it's out the front and out the back that's where you will get the highest readings by measuring that way. And because of that, we have to do measurements in a certain manner, and I'll show you that in the next slide, but this will just show you where the inputs are. So it's a micro USB that gets plugged into the power jack, and that's your input power to keep this running continuously. It won't run on battery mode, it'll run on micro USB. There's a headset jack up here, or a headphone jack up there too, so you can still listen to the, you can have the volume off, but you can still listen to the sound through a headphone jack. Then we have our volume, low, medium, and high. And the sound is, the device is off, or the device is on without sound or on with sound. Depending on where you are, you may not want to play the sound very loud. And then you have this max reset button. So you can see the maximum value we've been measuring here for a few moments. Right now, the peak is 2 microwatts per square meter, 2.99 to be exact, and the maximum we had. So there must have been a device going off in the area at the time. So we can see that max pulse we got hit with was, almost 7,000 microwatts per square meter. But then again, when you look at the average, it's 0.025. So you can see so that tells me, I know we're measuring pulse digital signals because the average is so low. And, there's definitely a pulse because we have that high reading in there as well. So just a little bit of background on the meter there and how to do your measurements, but also looking at, anytime you have an RF meter, you want to know the antenna patterns of measurement. So, we know it measures out of the front and back very well, but here's what it looks like from the top view. So it kind of is like, it almost looks like a figure 8. So the sides of the meter, let's see here, the sides of the meter, that's kind of the quiet area. It doesn't really pick up strong signals in this area. It picks up the strong signals, in this range here and in this range here, in this direction here. So it's very important to understand your antenna patterns, because it teaches you, it shows you how to do the measurements. And you want to try and point this at the source to get your maximum reading out of it. So yeah. And for sleeping area assessments, this is where we need to kind of use this figure 8 pattern. So, and what this does is it causes those two directional arrows to rotate in all directions in order to capture your highest reading. So I've got a demo here. I've asked my daughter to demo this for me, and we'll watch her in action here. And it's also important to use the max hold feature too, because you want to hold that maximum reading. So you want to scan the complete surface area of the bed. And typically we use it in the sleeping area to do these scans. Do a scan for 30 seconds or so. This is going to be much quicker than that. But yeah, you just want to look at your max reading for that time you're doing the scan, and then you can reset and hit max hold again and do the reading again. And once you do that 2 or 3 times, it'll give you a good idea of what your exposure is in that sleeping area. So I'll go ahead and play this. So you can see the figure 8 pattern that we're doing here. And that rotates that antenna in all directions so it can capture signals hitting that area that are coming from the top, the bottom, the left and right. And then you'd basically do it again. You do this 2 or 3 times and look at your max hold reading. And then that'll give you your exposure in that sleeping area. That's kind of the methodology we've developed in building biology, and that's really the kind of way you have to use this meter in order to do a surface scan of a sleeping area. If you're trying to do source detection, you can also do it with this meter, but do it with the meter in front of your body, so that when you're doing your readings, your body from behind is blocking the RF coming from behind you. So you're only picking up what's coming in front of you. So you can do a walk around with that meter close to your body, and it will help you detect sources easier. It'll shield everything coming from the back and only kind of grab what's coming at you from the front. So we'll do a little demo of this as well. So yeah, you use your body to shield from behind, and you walk around with the meter, and you can look at the levels, and you can listen to the sounds. And the higher the sounds or higher the levels, that means you're pointing more directly at the sources. And indoors, it's really challenging to measure sources inside, because these signals seem to be bouncing around outside or off of all the walls and ceilings and floors. So it can be deceiving a little bit to try and find some of these sources, but this method helps you sort that out a little bit. It's not perfect by any means, but it'll help. RF signal identification. So here are some of the typical sounds we hear in our homes. And these sounds are the modulated low frequency pulses. They're in the audible frequency as well. So we can only hear up to about 20 kilohertz. So there are still sounds and frequencies above that we can't translate into audio tones. Maybe our friendly pets at home can hear them, but we won't be able to hear them because we only up to 20 kilohertz. But here are the typical sounds that you would hear as we do assessments for people. This is the primary 3, I would say. That sound is probably pretty familiar to a lot of you if you've done any of these measurements. It's a Wi-Fi router, and that beacon signal is coming across at 10 hertz. So that means it's pulsing 10 times a second. And the carrier wave it's transmitting on is 2.4 gigahertz. In this case, newer routers, there's the 5 gig routers as well, 5.8 gigahertz routers as well. They would do the same thing. Then we have cordless phone. So that's 100 hertz. So you can hear the difference in the tone of the frequency or tone of the sound. So that 10 hertz is a much lower tone than this 100 hertz tone. And this just happened to be a 1.9 gigahertz signal, but it's 100 hertz, 100 pulses per second. So then we have cell phone towers. You can hear the pitch is even higher. So that tells me right off the bat, it's going to be higher frequencies. So that's going to be somewhere in the 200 hertz to 20 kilohertz range, somewhere in there. All those various frequencies that we hear off of all the transmitters in those towers. And cell phone transmissions the carrier wave is typically 600 megahertz all the way up to 2.6 gigahertz. And they're going into the 3 and 4 gigahertz range shortly, I would imagine. I know those transmission channels have been sold recently. I know people are bidding on them at this point in time, cell phone companies. So typically when we go into a home to do an assessment, we hear all of this. So this is kind of what it sounds like here. Right, just a bunch of mixed up sounds. And it's good because now just by listening to that, you know, there's 3 issues you got to deal with. I hear a cell phone tower, I hear cordless phone, I hear Wi-Fi router. So if I'm going in a home doing an inspection, those are the things I'm going to start looking for. And once I eliminate those, then I'll do another scan and see if there's anything else. Of course, you can't measure the cell phone towers. Basically, you would take care of all the indoor sources first and then see what you're left with. And then you would replace the indoor sources with friendlier technology. If you're getting hit with a cell tower too, then you got to get into some shielding. And that's a whole different ball game when we do that. We'll touch on that a little bit later. And then this is our safe and sound micro. So its operating range is 700 megahertz to 9 gigahertz. And it has 4 LEDs with various stages of flashing that will basically, if you're in meter mode, it's actually a meter and alarm. So in meter mode, you know, these LEDs at the bottom here will tell you what exposure range you're in. So if you've got a green light on, then you're measuring 1 to 10 microwatts. If the green light is flashing, you're less than 1 microwatt, and so on. So green is good, and you can see red is bad. You know, we start red at, you know, 1,000, we go up all the way up to over 1 million. So that's kind of the measuring range of that. And it's a monitor. You know, you can monitor RF discreetly wherever you go. You just strap this on your wrist and you're good to go. And it has 8 configurable RF alarm thresholds. So I can set the threshold to be any one of these levels, like 1 microwatt, 10 microwatts, 100, 1,000, 10,000. And when I pick up a signal of that strength, there will be a gentle vibration on this unit. So it'll alert you by vibrating, and you can have 4 different vibration intensities just in case, you know, you want to adjust it in some way as well. So I continually wear it. I just don't have it on me today. I'm just charging it right now, but the charge will last for 2 or 3 days. It's pretty good. And eventually we'd like to have data logging on this too, but that is getting all this technology shrunk down to a package of the size was a real challenge. And it'll be a bigger challenge getting this equipped with data logging capabilities too. So it also has just 4 color-coded LEDs that basically green is good, red is bad. And you have yellow and orange in there too. And it will measure down below building biology guidelines of 1 microwatt per square meter, and captures the fast pulses as well, pretty flat frequency response. And it will pick up the 5G signals, the mid and low bands as well, which is really important. That's individually calibrated. Again, made in Canada. Boards made in Silicon Valley in the US for us, and we try to keep an environmentally friendly design. Okay, so that ends the RF section there. So if we take a look at the EMF section, electric and magnetic fields, we've got gigahertz solutions meters, and this is called the ME3830B. There's also a ME3030B, and they measure electric and magnetic fields, and these are caused from anything that uses power, electrical wiring, overhead power lines, things like that. And so it's an AC electric and AC magnetic field meter. It's good to put the AC in front of it because it's not a DC meter. These are also known as Gauss meters, Tesla meters, or EMF meters. And in this case, it's a single axis electric field and a single axis magnetic field. So that has some drawbacks, but the positive about these meters are they're very sensitive, and they reach 100 kilohertz and above with some of the models. And most North American meters don't assess frequencies that high. So that's one of the advantages of these meters, is they're super sensitive, and they analyze very high frequencies as well. So they have an LED display which indicates the sum total of the field strength of all sources. So it's like a broadband meter as well, within that frequency range of 16 hertz to 2 kilohertz, or 16 hertz to 100,000 hertz. They have an audible tone, like a Geiger counter effect. So it'll tick louder and faster as you approach a source, and it'll tick slower when you move away from the source. And I've got a video to show that as well. So it measures mag fields in nanotesla. These are German meters, and they measure in nanotesla. But 100 nanotesla is 1 milligauss. So basically it's a factor of 100. So you would just move 2 decimal points in order to get that in milligauss. And also you can see over here too, some people mistake this for a decimal point. It's not really. This is the unit of measurement. So we're measuring magnetic fields, and it's in nanotesla for this measurement. If it was electric fields, this dash would be up here. It's not a decimal point. So this is actually magnetic field reading in nanotesla. So it'd be 437 nanotesla, or 4.37 milligauss. So that's how you'd read that meter. So electric field is measured in volts per meter, and that's something that's a standard unit of measurement for electric field. And it is sensitive down to building biology guidelines, 0.1 milligauss, or 1 volt per meter. And these are made in Germany. There's 2-year warranty on these, 2-year warranty on our meters and watches as well too. So here's an example of how you would use it. Because it's a single axis meter, you have to rotate it in multiple directions. That's part of the challenge, but we'll show you here how it goes. So there you can see how the readings change with the direction of the meter. And yeah, definitely pointing directly at this switch gives you the highest reading. So that's the value that we would use when we're assessing the exposure here. Same way with electric fields. With electric fields, you can ground the meter as well too, and get measurements that way. And the previous building biology guidelines we listed earlier, they have the electric field exposure levels and magnetic field exposure levels as well. So you can compare them to those guidelines. Just an explanation on single axis meters here and 3-axis meter, just so you understand what that actually is. So on the magnetic side, a magnetic field sensor basically is a coil. And so a single axis magnetic field meter would have 1 coil. And you can see here that this is a ME3951A, it's a gigahertz solutions meter, and you can see the single coil right there. So that's the reason why we have to rotate it in 3 directions. And on the electric component, or the electric field measurement, it's kind of the same thing. We have a plate here. That's the electric field sensor. It's at the front of the meter. And that's the reason why we have to point the meter in order to assess our exposures, because we have to point it in the direction of the highest field. And that's the disadvantage of single axis meters. The advantage of these meters are they're so sensitive, and they cover large frequency ranges. Like this goes up to 400 kilohertz. Then if we look at 3-axis meters, so it's the same thing we're talking about for a magnetic field sensor. You have 3 coils instead of 2 coils. And these coils are positioned in this location for this NFA 1000. There are lower cost 3-axis meters out there. UHS2 we carry from Alpha Labs. And we're going to be developing one as well ourselves. And same with the electric field sensors. Three-axis meters have 3 plates, electric field plates. There's not very many electric field meters out there that do 3-axis. This NFA 1000 is the most economical, and it's roughly comes in at around $1,900. Other ones out there, you know, they range from, you know, $5,000 to $10,000. So it's really difficult making a 3-axis electric field meter. Gigahertz Solutions did it brilliantly with this NFA 1000, but there is a cost to it, unfortunately.
Before you go on, may I ask you a question for
Certainly.
clarification?
Sure.
So you talked about with the radio frequency meters, how you want to keep that distance now to be in the far field. But when it came to the magnetic field, you are right up close. So it's okay to be up close. And the way you did it was also different. You didn't do the figure 8. And do you add up the numbers to get the total number?
Yeah, you could.
My 2 questions.
Yeah, you could, like, technically in building biology, you would place the meter in 3 axes. Your x-axis, your y, and your z-axis. And then you could do the root mean square of those, add those up and square them, and you know, get your RMS value that way, which is more complicated. So there is a more technical way to do that, and it talks about that a little more in the manual, and we teach that on courses. We're just trying to, I was just trying to simplify things for people this way, but there is a true technical way of doing it that you're exactly right. And we can get up closer to like these are near field meters as well, so we can get close to the sources. There's no problem. It's just the RF meters are the far field meters. Yeah, so we've also put together some kits here too. And one of the kits we have is called the MK5, and it has a Gigahertz Solutions 3030B meter, as well as the Safe and Sound Classic 2 meter. We also have, there's a typo here, sorry, this should be MK15, MK15 meter kit at 645. It has the more advanced 3830 meter from Gigahertz Solutions and our Safe and Sound Pro 2. So either one of these kits is a good investment. When buying meters, it's good to invest as much as you can. You know, everybody has a budget for sure, but if you can afford the Safe and Sound Pro 2, I mean, that meter is, for an electrically sensitive person, is probably the best investment that person can make. So we offer it in kits here as well. And future meters, we're planning on an EMF meter combined with a body voltage meter. It'll be lab tested for sure. It'll do 1-axis electric field, it'll do 3-axis magnetic field and body voltage, and it'll be housed in the Safe and Sound Pro 2 case. So that's currently what we're working on at this moment in time. And you know, hopefully in the fall we'll get this meter out and rolling, and it should be a good addition to what we already carry. And just touching on the body voltage part that we look at as well. Here's our body voltage meter kit. At this point in time, it's basically a really high-end true RMS multimeter, and you can connect it to. You have to connect one end to ground, and in this case, it just has a receptacle outlet adapter that you can plug into a receptacle to get ground, and that's where the black leads go. Or lead goes into the common port on this voltmeter or multimeter. And then we have our hand probe that the person holds on to, which goes in the positive socket here, the red cable. And when we're measuring AC volts. And you can see this subject here. We have the meter here. We have the ground wire going on to either earth or an electrical ground. And the subject is holding on to the probe right here. So that's how we do body voltage readings. And ideally, we want less than 10 millivolts on these. And basically, what is body voltage? So basically, it's a surrogate measurement of the electric field. So we saw that we had those electric field meters. Body voltage measures the amount of electricity that's coupled onto your body, because all the live wires around us radiate this electricity, and it surrounds us continually. And it likes our body because it's a large mass of water and minerals. So electricity loves it. So it likes to cling on to us, and we can actually measure it. Like, this is a voltmeter. It measures voltage on our body, and that's, our body communicates with voltage signals. So this is definitely not a good thing for our body. So typically we use this in sleeping areas to determine which breakers affect our sleeping area. And then we can go down to the breaker panel at night and shut off the particular circuit breakers, or there's automated ways to do that as well too. But we just want to lower that overall electric field and body voltage reading when we're sleeping, because this is where your body does the most repairing when you're sleeping. And we definitely want a quiet area to sleep in. And another important thing too is this meter kit comes with an outlet tester. So we definitely want to test the outlet before we plug this meter into ground. This will go into the electrical socket, but you want to test your socket to make sure the ground is valid and working beforehand. And then also this picture down below it, that's a picture of a ground rod sticking in the ground, basically. So that would be a ground peg that we use. And, that would, this 20 foot cable would go out the window, and you could stick that into the earth. And then the person would hold on to this probe. And that's how you would do your body voltage reading with an earth ground. So you can do it with an electrical ground or earth ground. There's pluses and minuses to both of them, but there's just two ways of doing that. And here's a close-up of this as well too. Yeah. Another picture I wanted to give to you was the Gigahertz Solutions has other types of meters, and I just wanted to show you the reception pattern of these other meters. So the one on the left here is the directional antenna, and we use this to find sources. And you can see the antenna pattern kind of goes out in front of the meter. It doesn't capture much on the sides, but it captures much right directly in front of it. And that's kind of a little bit similar to our Safe and Sound Pro 2 if you shield it with your body behind it, but this does it automatically. So great meters to use for when you're shielding. If you've still got sources or leaks, these meters are the higher end meters from Gigahertz Solutions that we use, and train building biologists to use to really pinpoint and find those sources. So with just basic and general meters, you can still do a good job. You can get 95% of the issues. It's that last 5% that the electrically sensitive have difficulty with. That's where you need really high-end meters to sniff out those final little sources of radiation. And so then we also have an omnidirectional antenna. It measures 360 degrees, and we use this in that figure 8 pattern as well in order to assess our radio frequency exposure in sleeping areas. So you can see the antenna pattern with this. It's like a big donut. It doesn't capture a lot above it or below it, but it captures a lot 360 degrees around. So again, this is one you want to angle at different angles and twist it left and right and up and down when you're doing your figure 8 pattern in order to cover all the directions, in order to get all the sources that you need. So it's just good to see this, because when you can picture your antenna pattern, it allows you to measure better and you get a better understanding of what you're doing. And I hope it's okay. This is a plug for Dr. Magda Havas. And she's using our Safe and Sound Pro in her global EMF monitoring project. So she has, she's looking for volunteers. If you have one of these meters or are going to get one, she will, you can join her group and be part of her studies. And basically, there's three aspects to it. She's covering all cities in the US, well, in North America and the world, actually. And she's rating basically each corner of a city and each intersection. And, green is low, green is good, black is high. And basically she's rating it and color coding it that way. So she's monitoring RF exposure all over. And getting input from hundreds of cities. Her goal is to get 1,000 cities up there, and I think she's at 300 or 400 at this point. Then she's also working on a project to monitor RF in the automobile, and she's just going to be starting that. We're developing a protocol for it right now, and so she's going to be looking for volunteers for that, because wouldn't it be handy to have a list of cars in the years, you know, knowing you could go out and buy a low EMF vehicle? That would be great. So she's trying to compile a list for that. And also she's measuring microwave ovens, because I've measured hundreds in my years of doing home inspections, and I haven't found one yet that doesn't leak. So Magda said, I think she found one, but I haven't. So, you know, that's another project she's working on, monitoring microwave oven leaks. And, you know, being in this business, we all know not to use microwave ovens anyways. So we just need to help promote that across the board, so we can kind of clear them out and, you know, get a toaster oven or something like that. Well, that would be a much better way than a microwave oven. And that is it for my slides, Theodora. So if you have any questions or comments, please feel free.
Yes, I have a lot of questions, and I think I've been pulling them off the chat. You can also put them in the Q&A. I'm going to do some short ones to start. And by the way, regarding microwave ovens, when my children's school measured the radio frequency, they found there were microwave ovens in every room, of course, in the classrooms for lunch. And they found that one of them actually exceeded, according to the NASA scientist who did the readings, the current FCC limits. I mean, it was old. So old microwave, they all leak. I mean, they all, you can just, anyone who's measured, you discover that, as you said. But when it's dirty, when the rims are dirty, or when they're older, then there have been studies on this as well. The leaks can be even more. So okay. I have a few quick questions, and then other longer questions, but let's start with the easy ones.
Oh, sure.
Can electrically sensitive people wear the watches? Do they have any low-level emissions?
Yeah, we sent out 30 of them to electrically sensitive people, and I've got all positive feedback. So we think we're good that way. There will be, when that vibration goes off, there will be a magnetic field that comes off the motor. So that hasn't seemed to affect anybody at this point in time, but that's about the only thing that will be an issue for anybody, possibly. We haven't really even seen that. You know, we've put a very noise-free power supply in it. It runs off of a battery. The casing is made from biologically friendly components as well. So we've done as much as we can in order to make it safe and compatible and comfortable with any electrically sensitive person. So so far it's worked out well. We've got probably 300 or 400 of them out there at this point, and have not heard that complaint as of yet. So, but I've dealt with thousands of electrically sensitive people, and if somebody is extremely sensitive, it's a possibility. I won't rule that out, but we've done everything in our power in order to make it as compatible as possible.
Thank you. Next question. Do we need to calibrate, or how long when you get a meter? What is the maintenance for the meter, and does it need to be calibrated? And if so, how does one do that?
Well, in industry, if we're doing official measurements for government or legal entities, typically it's a 2-year period. You need to get a calibration certificate every 2 years. If it's just a home use meter, something like this, I don't think you need to worry about it. I think that if you notice extraneous readings or readings that just don't make sense, then maybe we should get it in here and do a calibration, or to even compare it to a meter off the shelf, just to make sure it compares the same. But I like calibrations, they're good, but they're not really necessary. Once it's done from the factory, unless you're getting some strange readings, you generally don't have to worry about it unless you're doing, you know, a legal case where you require that piece of paper. And it's an expensive piece of paper as well, but it's necessary for legal and government cases. I would say you wouldn't need it unless you're doing something like that.
Okay. So I'll let you answer this question, but and a lot of people have asked in various ways. How do we compare the measurements to FCC or ICNIRP limits?
Okay. Yeah, for radio frequency waves, you know, basically the FCC guidelines are somewhere between 2 million and 10 million. So that is basically the numbers you're looking for those guidelines. And, you know, if you're truly measuring in the far field at a distance from all these sources, in my career, I've really never measured anything over those guidelines. And the only one time I was on a high rise in Toronto, and they had cell phone towers on the outer edge of the building, and I put my meters in front of the towers and they just went off the scale. So I would imagine that that would be over FCC guidelines. But, you know, if you're approaching 2, 3, 4 million microwatts per square meter, that's when you're getting close to that range of FCC guidelines. And if you get into that level, like this meter is designed to be sensitive more at the lower levels, because electrically sensitive people, we need to deal with the lower levels and clean everything up as thoroughly as possible. You'd be looking at more of an industry type of meter in order to compare to industry guidelines as well. You know, they're geared more for the 2 million to 100 million microwatts per square meter, where we're geared with, you know, 0.1 to maybe a million or something like that. You know, 0.1 to 100,000 is actually the really sweet spot for power for this meter. That's where it's the most accurate. So, but yeah, it'll produce numbers in the millions. And when you're up there, you're getting close to FCC guidelines, but chances are you're probably very close to a source and you're not in the far field as well.
Thank you. And the way the FCC measures, I mean, just in summary, the way they average, the way they put it forward is not relevant to biological impacts. And so it's really two different ball games.
Well, yeah, you bring up a good point there, Theodora. Yes, it's actually time averaged numbers that they're coming up with, and we're looking at peaks. So yeah, to clarify then, yeah, the average value that you see on this display, that's probably the value that the FCC is coming up with. So yeah, that's where it comes to the pulsed or average values or peak or average values. And that's what we talked about in that one slide. And industry uses more or less the average values to measure, not the peaks.
Okay, so we have a lot of questions. I'm not sure I can get to everything, but let me take a stab at it.
Okay.
When using the ME 3030B or 3038B, do we take the reading when the device is stationary, or do we take the highest reading when scanning? I ask this question because there is a huge difference in the reading when the device is on a stable stand. Sometimes the measurement is up to 200 times higher.
Well, in theory, we're supposed to place it on the 3-axis in a stand, and then take the root mean square of those readings. But if you're just doing a quick scan in your home, I would rotate it in all directions and take the highest number.
Okay, next question. And this question is brought up all the time, and I'm glad to add some things on to it as well. But what recommendations do you have for cell phones that have the least impact?
Yeah, funny story. I've been fighting this for years, but I had to purchase my first smartphone last year. So I'm not a fan of cell phones at all. You know, some that have lower SAR levels, great, but I still don't think it's the right thing to do is putting it up to your head and making a phone call. You know, there's better ways of doing it. You definitely don't want to be in contact with the phone when you're making a call, because the signals will couple onto you. Even if you have it in speakerphone and you're holding it, like those signals are going to couple onto your body and transfer through your whole upper torso. It's probably better than putting it right up to your head, but you know, speakerphone with it at a distance, I mean, that's probably the best way to use a cell phone. And you know, sure, if it has a lower SAR rating, great, but you know, the power levels seem to vary so much just depending on how close you are to the tower. You know, the cell phone automatically adjusts for it. So yeah, I'm not a proponent of using, well, lower SAR cell phones, sure, great, but I'm still not a proponent of using a cell phone, especially when you're putting it up to your head, no matter what the SAR level is.
Thank you. I'll add a little bit. You can unshare your slides as well. So there are a lot of things you can do with a phone, because the SAR level doesn't even necessarily correlate to what it's emitting, because of a whole other webinar that we could do on that. But turning off antennas when not in use, keeping it on airplane mode, of course, as much as possible, or completely powered off and using a corded phone. But if you must use a cell phone and you want to reduce, of course, there'll still be exposure. Also keeping apps off that are always constantly uploading and downloading. And again, keeping a distance is so important. And also being aware of when the phone goes to its highest power. So that would be when the signal strength is low. That would be when you're using a lot of large files. It might be video and pictures and uploading and downloading large files. So the one other thing I would add is that if you're near a lot of metal, or you have metal on your body or in your body, so there could be reflections or other changes in the environment. If you're in a basement, like in my basement, where the signal is very low, the exposure to myself would be higher if I decided to use a cell phone in that situation. So whatever we can do to use wired technology is really the best option there. So someone asked, do you know anyone who's actually gotten sick from excess electromagnetic radiation? And maybe you can just briefly talk about the work you do in making safer environments for people who've been injured.
Yeah, it's really hard to make the direct relationship between being injured by exposure and not. I know that, dealing with the electrically sensitive people we deal with, generally they tell us that if I get near a router, or if I get near, a cell phone, I feel strange, or there's different things that occur inside my body. I get headaches. I feel nauseous. We get that a lot. We probably talk to 10 or 20 electrically sensitive people every day that have these issues. So we know they're definitely happening out there. It's just difficult to prove that that's exactly what has caused the problem to start with. So yeah, that's our entire clientele is electrically sensitive people, and going out and doing home inspections and assessing people's homes, finding these sources, and just even unplugging a Wi-Fi router overnight and getting a call from the person the next day, man, I haven't slept that good in years. Or when we shut off breakers in the sleeping area, typically we get that same type of feedback. So I think Magda Havas has done studies where she actually witnessed a heartbeat doubling when a Wi-Fi router was turned on behind an electrically sensitive person. So there's all sorts of these events or actions that I've seen over the years that prove to me without a doubt that this does, electrically sensitive people do react to these type of signals. And the key for them is creating a place that they can recover, and a quiet place or a sanctuary where there's no electromagnetic fields. That has to be our home. When we go out into the world during the day, when we work, we have no, basically we just have to go out into this environment and do the best we can. And we're going to get hit with all sorts of, electric fields, magnetic fields, and radio frequency radiation. But when we get home at night, we just want to create a place that we can recover. And for an electrically sensitive person, that's what they definitely need. And they can recover and they can get better over time just by reducing their exposure and allowing themselves to heal properly at night in a place of low exposure.
Thank you. And what have you found to be some of the highest sources of electromagnetic radiation in homes?
Probably, yeah. When the microwave oven is going, and if you're in that same room, it's pretty strong. Routers as well, Wi-Fi routers, they have gotten stronger over the years. Man, when they first came out, there was just one little antenna on them, or some of them didn't even have antennas. Now it's, multiple beam-forming antennas or whatever they're coming out with. That, and that there was complaints of the first routers that there wasn't enough coverage in the home. So then they had to add higher power routers to cover the home better. So those higher power routers are definitely an issue. Cordless phones too. We've measured so many people's nightstands where they have their cordless phone, and it's the main base station that radiates. That main base station, yes, thank you, Theodora. That's a good example there. Those things are very strong. And, Wi-Fi routers, cordless phones, and actually that cell phone, when you have it, if you're far enough away from a tower, that cell phone will radiate pretty strong as well. As Theodora was saying, if you shield them, or if you're in a basement, or if you're in an elevator using it, it's going to increase its power to try and communicate with the tower. So I would say that, yeah, the microwave oven, Wi-Fi routers, cordless phones are probably the main factors inside of a home, and they're probably amongst the strongest sources that I've seen.
Thank you. And someone asked me to clarify what I meant by metal in the body, and I meant metal implants or metal in your mouth. But metal, there's studies that have been done where they have looked at what they were mimicking was a cell phone in the pocket along with keys or along with another metal item, which can change how that what will the exposure be, which can be really different depending on the situation. So that's what I meant by that.
Right, yeah, and on that line too, I've had one of my first clients was electrically sensitive. They knew it. They proved it to themselves, and they had a metal rod in their spine. And what would happen to them, where they really felt it, was getting on the subway. As soon as they got on the subway, they just felt awful. Tingling and all sorts of EHS symptoms came forward, and that was, yeah, it was because of a metal implant, a rod. I think it was a 6-inch rod implanted into their spine. So you're right. Mercury amalgam fillings as well will do the same. Eyeglasses, metal frames on eyeglasses, jewelry as well. So these waves like metal.
Yes, in fact, the government of India, just as a side note, when they put out their recommendations on how to reduce exposure from cell phones, they specifically talked about eyeglasses and metal. This was many, many years ago when they put out their recommendations for the general public. A real issue. I wear glasses, and quite a challenge. So let me read just another question. Oh, also someone wanted to know, can you turn the vibration off of I guess it's the watch?
Right. The watch, the minimal setting is so small that it's barely feelable. Like it vibrates so gently. There's not really an off feature, but if you wanted it off and just wanted to look at the readings on it, you could press the button and it would show you the LEDs would light up. You could just set the threshold higher you know, set it to 1,000,000 or set it to 100,000, and then it would allow that vibrator not to go off, but you could still intermittently check it by pressing the button to see what your levels are at. But there is not a complete disable of the vibration. There's just 4 different settings, and the lowest one is super low.
Another question, turning off the electrical breaker to a bedroom area. There's questioning that could have an impact on someone's electrosensitivity. Can you explain that?
Yeah, because I used to do this as well too. We were on the 2nd floor, my breaker panel was in the basement, and we would have to travel up and down 2 flights of stairs in order to shut those breakers off at night. And what you're doing is you're getting close to the breaker panel, and the breaker panel is a source for lots of AC electric and AC magnetic fields. And, you know, if the smart meter's nearby, it could be RF radiation too. And I know electrically sensitive people can have difficulty doing that. And I've seen people actually use poles to flip the breakers at a distance of like 5 or 10 feet. But there's other devices out there, cutoff switches, sleep switches, that can be set up to automatically shut the power off. But what they use is they use a remote control too. So it's just like a remote control on your automobile that you use for opening and closing the doors. I have yet to find an electrically sensitive person that's not compatible with that, like a quick burst of analog signal. So that could be done automatically instead. But yeah, it's a challenge anytime an electrically sensitive person has to go near a source. And a fuse panel, breaker panel, unfortunately, is a large source of electromagnetic radiation.
Thank you. Someone asked a question about silver and metals, and maybe you can talk briefly about shielding as well. So just for clarity, when I was talking about metal, I was also talking about how it can reflect and refocus the electromagnetic radiation. So the question is, silver and metals are used as shielding, but yet metals can be an antenna. I'm confused and I'd appreciate clarity. Thanks.
Right. So that's a good question. So metals, yeah, basically metals in the form of a flat surface act as a reflector. When an RF wave hits a metal shield as well, it still causes, basically the way an antenna works is if you have a vertical antenna, a wire, an RF wave will hit it. And what it does, it excites the electrons inside and causes vibrations inside the antenna. So that still happens inside of a shield as well. But instead of having a single point like this, if you've got a large surface, basically when a wave hits it, it acts as a reflector. So it'll still hit that piece of metal, and it'll cause the internal electrons in the metal, in the wires, in that shielded material to vibrate as well too. But on a large surface, metal will act as a reflector. And there has been talk about absorbers out there. People advertise absorbers, but I have yet to see an effective absorber that really works. I know the military this is critical for the military. If they could have a microwave absorber on their aircraft, I mean, that would stop radar and they would be basically undetectable in the sky. So I believe there's technology out there. I don't think the cost is not within our reach right now. They're probably for military use at this point, but if we could make a blocker that would absorb RF instead of reflected, that would be great. Unfortunately, every shielding material, every type of shielding material is a reflector at this point in time. And good point to bring up, because we have to be cautious of that. And when we get reflections off of this, like it's not going to increase thousands of times. I mean, if it did, I mean, we could make money selling power, like harnessing energy that way, but it just doesn't work that way. So typically we find, hotspots of, 1.2 to 1.8 times, maybe you get double the exposure in some cases. But you know, it's something to be aware of. You definitely don't want to increase your exposure when you're shielding the wrong location, shielding the wrong spot. You can do that. And that's why you always verify after you put up a shield. You want to make sure that you're not increasing your exposure. You want to make sure you're going in the right direction and decreasing your exposure.
Thank you. And I realize what I'm about to ask is a big question, but if there's any way we can just keep it to a few minutes because our time is up, and I appreciate you taking so much time. But if you have a small cell in front of your bedroom window,
Mm-hmm.
what do we do, and how do we fix this situation?
Yeah, that's a typical question we get asked a lot on a day-to-day basis, and it's happening all over. Basically, you want to make sure you take care of all of your inside sources first. So you want to make sure your Wi-Fi router is wired, no cordless phones, no sources inside the house. Unfortunately, the only way to really block that signal, unless they're willing to move the antenna, is to put up shielding. So then you gotta focus on all these points that we just talked about in the previous topic of reflections. So typically, if you want a portable mode of protection, you could install a bed canopy, and you know, surround your sleeping area with a bed canopy, shut off the power in your sleeping area, and that will give you an enclosure that will block, you know, 99% of the RF coming from that source. Unfortunately, when you're out of the canopy, it doesn't protect you. So that's the negative. If you wanted to do something to that point, then you would need to probably install some type of shielding paint on the walls and create like an enclosure for your bedroom, painting all the outside walls. So it's kind of like a Faraday cage type thing. And so the paint would be something you could put on the walls. Unfortunately, the window is a main factor of leakage as well. We have different types of window films you can put on the glass to block RF coming through the glass. If you have low E windows, you may be okay, and you can test that by with an RF meter. You can open and close the windows and see what kind of difference that makes. You could put up shielding fabric in front of the glass, in front of the windows, make curtains out of them to reflect radio waves away. Those are just the basics that can be done, and you know, you got to determine what extent you want to go to. Whether you just want to shield at night or you want to shield throughout the whole day, but then it becomes more involved if you want to shield your whole sleeping area or the front side of your house. Then you have to install shielding. Yeah.
Thank you. And also really important, and we always recommend that people use an expert when they're doing shielding, that they have a building biologist or electromagnetic expert to come and to really validate that shielding, because there's so many problems that can happen when you start putting that shielding up. And maybe you could talk briefly about the Building Biology Institute. Also, just to reiterate, safelivingtechnologies.com is the website for Safe Living Technologies. That would be, and actually one quick thing that someone brought up that's really important, that's about if you are shielding a space and you bring a device into that space, so you've got the shielding, then you bring in your cell phone, you're going to be then increasing that exposure to yourself, because that phone is trying to put its highest power to get out of the space. So you don't want to bring devices or sources inside the space. But please talk about the Building Biology Institute as well, if you could.
No, sure. No, that's an excellent point. Yeah, you definitely don't want to bring a source into a shielded environment. Building Biology Institute. So yeah, they basically they believe in a holistic approach to having a clean and healthy home environment. So it includes, you know, indoor air quality. It includes, you know, eating proper food. It includes using healthy building materials, reducing electromagnetic radiation, and they have certification courses that can certify you as a certified building biologist or an electromagnetic radiation specialist, and that's where I come into this. Back in 2008, I started developing the electromagnetic radiation certification course for them back in those days, and along with a few other engineers. And yeah, basically, there's two. That's for the electromagnetic radiation safety specialist. They have to take an IBE 212 course and an IBE 312 course. One's the basic electromagnetic radiation course, and then there's the advanced, is the 312 course. We have both of them going on this year in North Carolina. And yeah, I'm just drawing a little bit of a blank here. Yeah, we basically over the years we probably have about 250 certified electromagnetic radiation specialists and building biologists across North America, and we want to teach them how to measure, how to shield properly, and just get this information into their hands, and get the proper measuring equipment in their hands. And the Building Biology Institute has a list of find a professional, so you can find one of these inspectors in your area on their website. Plus, we also have a location on our website under our services that list the electromagnetic radiation specialists that we've worked with over the last 15 years, and we've vetted them, and we know they've got the right certifications and right measuring equipment in order to go out there and do the jobs. So we certify probably 30 to 50 of these guys a year, and maybe 10 or 20% of them go on to do this professionally. So it's a great resource for an electrically sensitive person to approach a building biologist. They have the resource of all of us out there. If they ever have a question, they can come to me, or they can come to any of the instructors, ask them for their opinion on a situation, and we can get the right solution in for most of the people. So it's almost like a family. It's a really tight-knit group of us inspectors that they have monthly meetings as well and discuss various problems. So becoming part of this group is a terrific idea if you're looking for a new career, or just interested in doing this type of inspection work in general. Improving your health, improving your home, improving your family's health. By all means, I would suggest taking some of these courses. And there's 2 live seminars to attend for the electromagnetic radiation course. Plus, the Building Biology Institute also has lots of online courses you can take as well too. So, yeah, I've been a part of it for 10 or 15 years now, and it's great. The people there are wonderful. They have the best of intentions, and they're all about helping people that are sensitive to these fields and implementing solutions in there. They're all dedicated to doing this, and I can't speak highly enough about the Building Biology Institute. They're great to work with.
Thank you so much, Rob, and thank you for joining us today. And thank you to all the patrons who are on. I truly appreciate your support of Environmental Health Trust. I want to reiterate that the website, safelivingtechnologies.com, where Rob and the organization has all of these meters. We have a referral code, EHT05. You can get 5% off and also support Environmental Health Trust through that link. And we thank you for collaborating with us and sharing this information. Is there any other way that people can continue to learn about how to use the meters? Do you have a YouTube or any way people can learn more? Because there are a lot of questions. And
was there? Yeah. So
we joined a course, but
yeah, the online courses at Building Biology are definitely a good way to learn. We try to make videos on each one of our meters on our website. So chances are there'll be a video explaining how the meters work on the website as well too. You can also call into our office as well. We've got 2 or 3 live technicians that are on the phones all day long and help answer these questions for people. So yeah, we're there to help and support our meters and help you understand what all these fields are all about.
Thank you so much.
You're welcome. Thank you too, and thank you for the great work you do at Environmental Health Trust.
Thank you. Bye-bye.
Bye-bye.